Hey everyone, my name's Andrew Lowe. I'm the Chief Advanced Visualization Engineer for Rolls-Royce North America, and I am here to talk to you about why everyone that uses 3D CAD should be trained and equipped to create and consume VR content directly themselves. A little bit of background on me. I first started doing engineering CAD research back in 2007 as an undergrad at Purdue. Not showing the presentation, are we? There we go. So as you can see in that picture, using a bunch of antique VR hardware, ended up doing research there, staying for grad school, and then inside Rolls-Royce, I built up our engineering VR capability from the ground up, and now I am the technical and strategic lead for XR for our defense business globally. So before we get into the details, because engineering VR is not something that you see a lot at conferences like this, I wanted to explain some of the conceptual reasons why it's so powerful. And the first is that VR offers enhanced understanding. And by that, I mean it's not relying on deliberately displaying false information to the user to trick them into perceiving depth that isn't there. So because it doesn't do that, because it offers an intrinsic sense of scale, you get a much deeper, much more accurate understanding of the geometry you're looking at, how it reacts to geometry near it, and how the total system would look in the real world. And I know you're probably wondering why this picture for this slide. Starting in the early 90s, Dr. Judy Vance from Iowa State and several of her students released a series of groundbreaking studies proving that enhanced understanding for just about every facet of engineering graphics, from simple design to mechanical design to every flavor of FEA and design optimization. And for the majority of those studies, they used that headset. That is a fake space Boom 3C that uses a pair of CRT monitors at a crisp 1280 by 1080 total resolution. It can display both red, green, and blue pixels, but not all at once. And just for context, the most powerful supercomputer in the world when that headset was released has about 3 orders of magnitude processing power less than the mid-range GPUs we are deploying in VR laptops to our engineers, and 4 orders of magnitude less processing power than an RTX 5090. So if they could prove the power using that tech, what excuse does anybody have to not be using it now? The other part of what makes VR so effective for engineering is enhanced communication. So when you're trying to process a fake 3D image on a 2D screen, you're actually taking up quite a bit of cognitive overhead, taking up quite a bit of your brain's processing power, just perceiving what it would look like in real life, what the real scale would be, what the real interactions are, processing those optical illusions. And everyone does that differently as well. So you would be surprised at how many engineering design discussions that look like a technical debate over a complex design topic are actually just a group of people subconsciously trying to get themselves onto the same perceptual page about what they're looking at and what they think it is and how it interacts. And then on top of that, it also, VR takes away that cognitive overhead, so you can make better decisions faster because you don't have that constant bit of your brain in use. And also, too, it removes a lot of the need to try to verbally explain complex thoughts, complex ideas to other people in a way that they can understand, because you can just point and say, yeah, that. So feedback from our design engineers and our design teams using this has been that about 30 minutes in VR is taking the place of 3 weeks of design meetings. So with the conceptual stuff out of the way, I wanted to provide some specific examples as well. This first one is actually the first design engineering use case we ever did in Rolls-Royce in the US. And so I knew from previous experience that when you're working with NURBS geometry in VR, you end up with really crippling poly counts, and I just wanted to get the most complex CAD model I could to benchmark my hardware, see what I could do. When the benchmarking was done, I used that model, which turned out to be a model of a test cell that was going to be built in a few months for one of our engines. I just turned that into a demo and I started showing engineers. And 5 minutes after putting on the headset, when the test cell engineers saw this, despite the fact that they've been working with this in traditional 3D CAD on a 2D screen for about 4 months, they found roughly $90,000 worth of errors that needed to be fixed. Stuff like HSE problems, accessibility problems, risky location of oil and fuel lines, instrumentation issues. So they got very excited about that. We ended up doing a series of 4 comprehensive VR reviews with everyone involved in the program, from the UAW fitters and electricians that would be installing the engine, all the way through every flavor of engineering to even the program management. The list of stuff to be fixed ended up being 3 pages long, would have taken about $250,000 in material and labor to fix, and that fix would have taken about 9 weeks. And because this is such a critical bottleneck in any engine program, where engineers are waiting on test data before they can do anything else, finding those before we went to physical parts saved about 135 engineers from sitting on their hands doing nothing for 9 weeks. The second use case that I wanted to talk about was for one of our marine power packages. It's essentially an airliner engine in a box connected to a generator, and that powers either the propulsion or the electrical system of a large ship. This particular model, the customer had spec'd with an electric starter motor, and after having it in service for a while, they started to think, hey, maybe it's not a great idea to have our electrical generator started by an electric motor, because if the power goes out, we can never turn it back on. So the solution we proposed was to pull out that electric starter motor and replace it with a helicopter turbine engine that you see in that middle square there. They're small, roughly the size of my torso. You can start them with what's essentially a car battery, and then you can use the exhaust flow from that to spin up the larger engine. Because of the nature of how shipbuilding works and the size and cost of the parts involved, they don't really prototype. They go from CAD to straight to production. So the naval guys were really happy to have the opportunity to look at this in VR. And again, within 5 minutes of putting on the headset, they found that the back third of the engine, the new helicopter engine, couldn't be accessed to be serviced. And they were 4 days away from design finalization. So instead of finding this out after it had been put onto a dozen ships and having to redesign, remanufacture, and reinstall everything, one guy went back to his desk, shifted that engine 3 inches, and had the design fixed before lunch. So why did I pick these use cases? They're not particularly innovative. There's nothing groundbreaking about what we did. And that is exactly the reason I picked them, because they were both completely dumb simulations. There's no interactivity. It was just looking at the geometry stereoscopically that enabled all this. And honestly, probably 80% of the benefit we get, you can get from just looking at the dumb geometry. So those 2 use cases delivered cumulatively significantly more than $5 million in cost savings. And with the tool sets we have now, it would take roughly 30 or 40 minutes of labor to create them. So that's kind of a ridiculous ROI. And then on top of that, because it's so simple, the time it takes to train an engineer with no VR background to go and create those simulations themselves with no help is about 90 minutes. So when you factor in 3 decades of proven power, that level of simplicity and just ease of use, there's really only one logical conclusion, and that's that everybody should be using it directly. The model you typically see for engineering support for VR visualization is kind of the centralized visualization model where there's a team that gets models from an engineer. They build the simulation, they get back in touch with the engineers, they come down, they consume the simulation. That works great at small scale, but like at my site in Indianapolis, we have 1,200 engineers, we have nearly 10,000 globally. And the size of a group you would need to centrally support visualization for that many people, it's just not feasible with the revenues and profit margins from traditional manufacturing. On top of that, the skill sets you would have for those people, those central visualization people, they bleed over and have a lot of overlap with much more lucrative industries like tech and finance. And you would be stuck in a perpetual retention and attrition problem. But it's easy to teach. The hardware is cheap. The laptop and headset kits we're giving out to engineers are less than $4,000. Software licenses for VR are eye-wateringly expensive if you look at it just from a purely per license standpoint. But when you start spreading that across multiple groups, using it for multiple programs, it becomes almost trivial. We pay a lot for VR licenses, and they typically pay for themselves a couple weeks into January at the beginning of every year. So that's where my conclusion comes from, is that you should be, everybody should be using, that the consumed 3D data should be consuming it stereoscopically somehow directly themselves. But as I'm sure you're all aware, saying we're going to give everybody cool new tech and actually giving everybody cool new tech in a big company is drastically different things. So I wanted to run through a few of the typical barriers you'll run into and some strategies for breaking them down. So the first one and the biggest one that you're going to run into is bureaucracy, whether that's IT, whether that's security, whether that's finance, or just the politics of building support to do anything. There's just a lot of hoops to jump through. So I highly recommend starting just trying to snowball benefit. Pick a very good pilot or POC, use the benefit from that to justify a slightly larger project, and rinse and repeat that until you have the support and the money to go through your productionization process. And when you go to that productionization process, start at the end. Do not start at the beginning. And by that, I mean the actual work that goes into putting VR hardware and software on your corporate network is trivial. It's guaranteed. It's one guy that's packaging and uploading the install files and checking a few boxes to make them available to people. So if you find that one guy and ask him what hoops he needs you to jump through for him to be able to do that, I guarantee it's going to be a lot faster than submitting an IT ticket and just going through that IT purgatory. For example, when I first productionized our VR hardware and software, it took 4 years. When I updated everything to brand new hardware, brand new software, it took 3 months. So that's start from the end is great advice. The second thing you're going to run into is user resistance, whether it's people that are scared to put the headset on because they think it's going to make them sick, or people that just don't like it because it's new and it's not the way they're used to doing things, or a variety of other reasons. Usually getting the headset on them is enough to break that down, but not always. So I like to start with a very targeted approach of who the initial adopters are. You go for people that are enthusiastic, open-minded, forward-thinking, and people that are going to go out and use it because they like it. And they'll start that snowballing benefit thing themselves in their own little corners of the business. And then from there, it's mostly peer pressure. It's, I didn't want to use this VR stuff, but now the rest of my team is doing our jobs better and faster than me. I'm going to have to. We have situations like that, and eventually it'll start getting to leadership, where leadership will start requiring it for people under them, and that opens a lot of doors. Then when you have all those doors open and you're starting to bulk train people, another thing you run into is just it's not a typical engineering skill set. I do VR demos for every new crop of interns we get every summer, and honestly, the familiarity of VR and engineering applications of VR with the interns every year really isn't that much different than career engineers that are a handful of years away from retirement. So it's how do you get people to pick up VR skills that just have no base in it whatsoever. And the best way to do that is very narrow, very focused, and very modularized training. The bigger the gap there is between when somebody gets training and when they start using that knowledge, the more knowledge they're going to lose. So I have very short 1 to 2 hour training packages that teach you just what you need to know to get going. I time the training so I know they will immediately be able to start using it, and make it known that if there's more stuff you want to do, there's more packages available, and every little bit more advanced knowledge comes with another 1 to 2 hour training package that they can go and start using immediately. And then finally, how do you sustain this at scale? And there's two kind of components to the problem. The first is just the tech side. How do I keep my hardware and software up to date? And then the second is the person side of how do I support a user base of hundreds, potentially thousands of people with this teeny tiny little central group of SMEs. So the tech side is relatively easy, and you approach that kind of the same way you approach productionization, is you find the person that does the work in IT, build a relationship with them, and if you have IT issues that need to be dealt with, talk to them directly. And make sure when you pick that person, it's somebody that understands what you're doing with the technology, the architecture it was implemented with, and that sort of thing. And they can take care of issues nearly immediately rather than putting yourself in IT ticket purgatory. When it comes to the person side, developing a network of super users makes that way, way easier. So every time you train somebody, keep your eye out for anyone that picks it up a little faster than anybody else, or anyone that is a little more enthusiastic than anyone else, and you put those people on a list. And that list of people you keep in close contact with, you show them cool stuff you're doing, you peer pressure them into wanting to do that cool stuff too, and you give them more and more and more and more training than the rest of the groups. And then they can become the POC, the SME for their little chunk of the business. And if there's questions, it'll go to them first. If there's complex use cases that the average user can't support, they can usually support it. And anything that does filter up to the true SMEs at the top level is complex, important stuff that's worth their time, and it filters up in low enough numbers that they don't get overwhelmed, and you can actually provide legitimate support. And then finally, how does this integrate into a larger digital engineering strategy? And contrary to what you'll see at a lot of vendors, your VR sim is not a digital twin. It's not a digital twin any more than a photo of an engine is an engine. It's kind of the icing on the cake, not the cake itself. What makes digital engineering truly powerful is a lot of physics and simulation and complex math and complex applied statistics and hyperdimensional relationships that are really inaccessible to the average person, or even to a very smart person that's not an expert in the area. And when you start talking, communicating about what makes your company so good, why you're so good at digital twins, digital engineering, most people will glaze over. But being able to show them VR, they immediately grasp the power of it. It seems cool and futuristic, and it can do the same job of conveying the message of, yes, we know what we're doing when it comes to digital engineering. And if you're dealing with someone that needs to know the details but doesn't have the background, it also, like for everything else, it's a powerful communication tool. You can use it to illustrate what you're doing with the real cake part of digital engineering in a way that won't make people's eyes glaze over. And we've had great luck with that, doing that for our customers and winning new business that way. So that is all. I only have a minute, so maybe I can take a question, but I'm also constantly on the app, so any questions you want to ask me, put them in the session Q&A. I'll get to them today, or just send me a message. We can meet up somewhere. They're happy to talk with anyone about anything. So thank you. Are there any questions? There's some in the back. If you can get them a mic. Got about 30 seconds. They need the mic so that people online can hear the questions, have a little context.
Perfect. Yeah, how are you guys doing this when you're working with suppliers or others that are outside of so if you're trying to integrate that situation you just showed earlier with a shipbuilder, how are you working, kind of like collaborating, I guess is the right word, across companies?
Suppliers typically don't have this capability. When we're working outside of the company, we're working with people we're suppliers for. So the Boeings, Lockheeds, Airbuses of the world, the airframers. And yeah, most of the aerospace defense industry uses the same one or two industrial VR packages, so you can just VPN together if you have a VPN set up and do collaboration directly in the same package.
I'm curious about how you're, I guess more specifically deploying this. Like, are you just going wholesale? What are you using? What headsets are you deploying? And like, is every engineer getting a headset, or is you're just drop it and one into person of contact on specific groups?
So because we're a defense company, we can't use anything made in mainland China. So we have two choices for headsets, and that's HTC products and Vario. Vario makes a Finland-produced, no China parts version of the XR4. That headset's like 15 grand, so you can't deploy that at scale. So we're using Focus 3s, and now that that's out of production, Focus Visions. And yeah, every engineer gets a headset. Every engineer that's trained gets a headset and a laptop that's VR capable.
And is this mandatory, or are you just
Not,
kind of asking?
We have two groups where the chief engineers have mandated that if you want their signature on your design, you have to go through VR at least once. Those teams have maybe 8 or 10 VR trained people and a group of 100 to 150. We're still kind of early in the penetration. We've got close to 50 engineers trained across 8 or 9 different teams. But the last of the bureaucratic barriers came down, so I'm hoping to have that more than doubled by this time next year.
That's great. I guess follow up, are they just using the CAD software they're using, or are you using secondary software?
Yeah, we're kind of the big 3 packages that are used for engineering VR: Autodesk VRED, Keysight's ICIDO, and Vertalis Visionary Render. Pretty much everybody uses one of those.
Okay.
And I think that's time, right? All right, thank you, everybody.